In this video, we're going to have a look at some examples involving the second index law. So the second index law is a to the power of m divided by a to the power of n is equal to a to the power of m minus n. So what it allows me to do is when I'm dividing with indices that have the same base, I can then subtract my powers, and that will enable me to simplify the expression. So the 4 steps I recommend when looking at complex questions involving the second index law is to rewrite the expression adding in any multiplication signs. The multiplication signs go in between the numbers and the variables. The second step is to rearrange to group numbers and like bases in the same order in my numerator and denominator. The third step is to divide or simplify the numbers in my numerator and denominator. And the last step is to simplify like bases using the second index law. So let's have a look at some examples. In this example, I want to simplify 4s to the power of 4 times 3s to the power of 6 divided by 6s to the power of 8. So the first step is to rewrite the expression, adding in multiplication signs in between my numbers and my variables. So that is going to become 4 times s to the power of 4 times 3 times s to the power of 6. And that's going to be divided by 6 times s to the power of 8. So now I want to rearrange to group my numbers and bases in the same order. So that is going to become, in my numerator, I've got a 4 and a 3. So I'll move them up to the front. So it's going to be 4 times 3 times s to the power of 4 times s to the power of 6 divided by 6 times s to the power of 8. Now before I move on to my next step, I can do a little bit of simplification by multiplying the 4 and 3 together to get 12. And that's going to be times, and then using the first index law, s to the power of 4 times s to the power of 6 is going to become s to the power of 10, because I'm adding my indices together, and that is going to be divided by 6 times s to the power of 8 in my denominator. So the next step in simplifying is to divide or simplify the numbers that are in my numerator and denominator. So in my numerator, I've got a 12, and in my denominator, I've got a 6. Now both of those numbers are divisible by 6. So 12 divided by 6 is equal to 2. So I can cross the 2 out and replace it with a 2. And 6 divided by 6 is equal to 1. So I can cross the 6 out and replace it with a 1. So that is going to now equal to 2 times s to the power of 10 divided by 1 times s to the power of 8. So the final step is going to be to simplify my like bases using the second index law. So in my numerator, I've got an s to the power of 10, and in my denominator, I've got an s to the power of 8. So that is going to simplify by being able to subtract my indices because I'm dividing with the same base. So using the second index law, that is going to become 2 times s to the power of 10 minus 8 divided by 1. And because I'm now dividing by 1, I no longer need to continue my denominator. So I can cross that out. So that is going to simplify down to 2 s to the power of 2. So 4 s to the power of 4 times 3 s to the power of 6 divided by 6 s to the power of 8 simplifies to 2 s to the power of 2. In the next example, I want to simplify 5h to the power of 3 times 8h to the power of 6 divided by 15h to the power of 5 times h to the power of 2. So my first step is to rewrite that expression, adding in multiplication signs in between my numbers and my variables. So that is going to equal to 5 times h to the power of 3 times by 8 times h to the power of 6. And in my denominator, it's going to be 15 times h to the power of 5 times by h to the power of 2. Now the second step is to go through and group my numbers and my like terms together. So that is now going to become 5 times 8, because I'm grouping my numbers in my numerator, times h to the power of 3 times h to the power of 6, divided by 15 times h to the power of 5 times h to the power of 2. I can simplify that a little bit more in this step by multiplying the 5 and the 8 together. So 40 times then h to the power of 3 times h to the power of 6 is going to equal h to the power of 9, using my first index law and adding my indices together. And that's going to be divided by, in my denominator, 15 times h to the power of 7, again using my first index law to add my powers together. So now I can go through and divide or simplify my numbers in my numerator and denominator. So in my numerator, I've got a 40, in my denominator, I've got a 15. So I can look for a number that divides into 40 and divides into 15, which is going to be 5. So 40 divided by 5 is equal to 8. 15 divided by 5 is equal to 3. So that is going to equal 8 times h to the power of 9 divided by 3 times h to the power of 7. So now that I've gone ahead and simplified my numbers, I need to go ahead and simplify my like bases. And I've got a h to the power of 9 and a h to the power of 7. Now, using the second index law, I know I can simplify like bases by subtracting my indices when I'm dividing. So that is going to equal 8 times h to the power of 9 minus 7 divided by 3, which is going to equal 8h to the power of 2 divided by 3. So my question simplifies down to 8h to the power of 2 divided by 3.